Hi everybody, this is a short video taking you through the basic fundamentals of doing your advanced higher geographical study. In this video I'll talk about the basic fundamentals of the introduction, the methodology and your first hypothesis. You should note that there should be 4 hypotheses and a conclusion, and that there's much more to a study, not least presentational aspects, but also further research and self-study that you really need to do to get a top grade. I certainly don't want anybody to watch this and think that this is how to get an A. It isn't. These are the basic, fundamental concepts that you want to try to adhere to. Starting off with the introduction. The basic concepts you can see on the screen are that your introduction should contain some graphical skill, some use of maps and diagrams. You want to contextualize where you are, wherever your study is. You want to use some form of map or diagram to contextualize that. When you're using a map to show where your study area was, you should label that map to explain why that study area is relevant, why it was a good place to choose, or some other reason why you chose it. Do not simply just include a map on its own and leave it unreferred to, because that is effectively just putting a picture in your study, and there's no marks for that. You want to show some kind of image that shows your transects or your study area to scale. You could use aerial photography, you could use an ordnance survey map of the area. There's lots of different types of maps you could use that would be appropriate. You could use photographs of the area to demonstrate what your transects looked like, what the stratification, if there was any, looked like, and how you carried out random sampling. Photographs of the area can be annotated by hand to show how random sampling was carried out. Perhaps you used a belt transect, for example. As you can see in point 3, photos of the area would be a good idea. You should include photographs of the area. You can annotate things like belt transects, as I've mentioned, but you can also just annotate them to show that this area was an area of parkland or woodland, or you can use it to show the difference between the 2 slopes that you've investigated. This is all to build the contextual understanding of where you went and the geography of that area. It's really important to do this because the examiner was not there with you when you did your study. They don't know the local geography of the area you went to at all. They need you to make that clear to them. You should probably try to include some kind of diagram in point 4 of your chosen study area. Most physical geography have systems diagrams or model diagrams that you can use to show what the soil forming factors are, or what a soil catena looks like, or what a river system would look like. You could use the Schum model, for example, in a river system. You could use the Brandt model. You could compare the 2. That would be quite interesting. There's various model diagrams of what beaches look like and how they're structured, and of course, if you're doing urban studies, there's lots of models that you could refer to. But using a diagram is a good skill to demonstrate, and it allows you to quickly and effectively communicate the contextual geography of that which you are studying. In point 5, a paragraph detailing why the study is of value to the subject of geography. That's really important. You should use this as an opportunity to demonstrate some background reading. So there's plenty of commentators, writers out there who are that you can quote, and they'll be explaining why this area of study is important to the subject of geography, or to the geography related subject. So it might be that your study is of interest to sustainable land use management. Maybe it's of interest to geology, or to ecology, or to environmental science. You should add to that a paragraph in point 6 about why this is of personal relevance to yourself. It might be that this has always been something you're interested in. It might be that it is of interest to your further studies in geography at university or college. It could be that you have a specific career interest. Nonetheless, any environmental study is going to be relevant to you at a personal level, so you should be able to comment on that. 7. A paragraph or two, I think would be a good idea, detailing what your expectations are of the study. What I mean by this is you should use your background reading to briefly summarise what you expect to take place. What does your model diagram that you've drawn in point 4, what does that tell us we expect to happen? Because kind of the rest of your study is really going to be compared against that. That point 7 is an important one. What are your expectations of the study? You'll see other examples of studies which include the aims in the introduction. It's entirely optional to you if you want to put the aims into the introduction as well. There's not really one way of doing this. I prefer to include those in the hypothesis section. Some additional ideas, it would also include, you can include other images, maps and diagrams. Only include if they add additional value to your study, and remember, if you are including a diagram or a map, you should refer to that diagram or map either in the paragraphs you are writing or in the label that you apply to that diagram or map. Things like photos of the area, other kinds of base maps, urban maps, geology, land use, traffic flow, all sorts of different maps might be relevant to your study. Any kind of relevant diagrams, and also make sure you are including references throughout. Okay, on to the methodology. The basic concepts of a good methodology are, first of all, to define to the examiner what your sampling strategy was. This might be easiest written up as a paragraph, but you can decide. There's 4 kind of concepts briefly summarized on the screen that you want to try and communicate. But basically boils down to this. Why did you go where you went? It's not good enough just to say, oh, it was around the corner, it was easy to access. There must be better reasons than that. Why you chose a steep slope and a shallow slope. Why did you choose an upper course stream and a middle course stream? What were the reasons for the area of forestry that you went to? This is what needs to be communicated here. You need to communicate kind of in point 2 I'm referring to here now. How did you choose where specifically to put the transects? Or if you chose study zones, where did you put those? How did you remove bias from that process? If you chose an upper course stream in a river, well, how did you choose which upper course stream? Did you just pluck it randomly from a map? Because you're going to have to demonstrate how you removed bias from that process. If you chose more than one transect, why? Did it offer grounds for comparison? If so, great. Were those comparisons, was one slope significantly different to the other? Was one slope vegetated differently to the other? Did it have different vegetation? In point 3, you want to go on to talk about how you organized your transects. Did you divide them into upper slope, lower slope, mobile dune, stable dune, CBD, inner city? We need to see how you stratified and divided up your samples. And if you did that, why did you do it? Did you stratify some areas for safety? Did you stratify other areas because they were inaccessible for some reason? Did you stratify them because they made for good grounds for comparison? Did you stratify proportionally? If you did stratify, you must tell us why. Did you sample systematically? Most likely that you did. What were the benefits of doing so? Did it allow you to carry out certain types of statistical analysis? And what techniques did you use to remove bias? Did you use random sampling? If so, how? Did you use random number generator? Was it a digital one? Was it a paper-based one? What were the benefits and negatives of that? Did you use a belt transect to sample within that belt transect randomly? There's all sorts of stuff there, but you do need to make sure that you communicate thoroughly your sampling strategy. And finally, did these methods of collecting data allow you to then set up appropriate methods of statistical analysis? Were you collecting ordinal interval data? Were you collecting significant amounts of data? Did the collection of that nominal data, ordinal interval, whatever it was, in collecting that, were you making sure to collect enough of it in order to be able to do the correct statistical techniques? Demonstrating that you're thinking ahead in that way is a sign of a good methodology. Also, you need to communicate in a succinct way the actual techniques that you did. We're not looking for essays on how to carry out vegetation, how to use a quadrat. Okay, what we're looking for here is some diagrams, some photos perhaps that show how the techniques were carried out, that perhaps show the equipment being used. You could do that in written form also, but a photo would be good. But most importantly, you're communicating the limitations. What were the strengths and weaknesses of the technique? Why was it good? Why was it bad? What improvements could be made for next time? You want someone else to be able to read your methodology and follow it like a set of instructions from which they should be able to carry out your study. And better still, they should be able to carry out your study and improve upon it. You should basically, as you can see in point 2, be communicating in whole for the methodology. You want to be communicating how you were able to produce a reliable, so that means without bias, robust, so statistically strong, with a good sampling strategy, and repeatable, i.e. a study which someone else can read the methodology of and do for themselves. You need to be able to demonstrate how those 3 qualities are built into your study. Alrighty, so on to hypothesis building. I can only give you a basic guide here, guys, because everybody's study is different. But first of all, you want to write out your aim. I aim to investigate factors influencing pH over a dune system. You then want to write a hypothesis. Clearly the hypothesis would have to refer to that aim. pH will vary, you're going to say, but it must vary because of something. So perhaps it has a relationship with humus content. You would of course have to phrase that as a null hypothesis as well. Now, what follows, guys, is a very basic guide to doing this, and there's lots of different ways to lay this out, and certainly lots of different ways to teach it and learn it. So, as I say, these are the basic concepts. You should probably want to graphically demonstrate your data. In this instance, the example on the screen, this is most easily done with a scatter graph, showing the relationship between pH and humus content. You then want to analyze this data. Well, first of all, you would describe any patterns shown in the scatter graphs. You're looking here for anomalous values, ones that are strangely high or strangely low and sit away from the line of best fit on your scatter graphs. You're looking for clusters of data on your scatter graphs. Are all the data points clustered near a certain end of the trend line? And are there any relationships that are, are there any positive or negative relationships that you can see? Are there similarities between graphs? Because you might have, if you've got 3 transects, you might have 3 scatter graphs, right? So are there any similarities that you can see? Are all of the transects positive relationships? Are they all equally positive? Are some less positive than others? Of course, to test the degree to which a scatter graph is positive or negative, you want to use a statistical technique. In this instance, where we have non-parametric data, you probably want to use Spearman's rank. Where you were using parametric data, obviously, you might use Pearson's. You could refer back to your methodology at this point. Now, here I want to pause slightly. Here, where you're using an appropriate statistical technique like Spearman's, you could either refer back to the methodology and add a paragraph saying where my data is non-parametric, I have only got 10 sets of data on a transect. It's not appropriate to use Pearson's, so I've used Spearman's. A little justification of why you're using your statistical technique will do no harm. You can include it in the analysis, but it might fit better in the methodology. Okay, so on to point 3. Having done your statistical test, make sure you include some evidence of having carried out the statistical test in the study, quoting the degrees of freedom, for example, showing the results table, or a snippet of the results table, so you can show how you've established your degree of certainty, and make a conclusion. As you can see, I've written one at 15 degrees freedom. I'm less than 95% certain of a relationship, so I have to reject my working hypothesis and accept the null hypothesis. Regardless of whether you are accepting or rejecting, what you want to then go on to do is make further analysis of that result. One way to do this is by graphing each of your variables. So we had humus content and pH. If you were to make graphs of each of those variables, you might find that the graphs have anomalies within them that allow you to explain the reasons that Spearman's was not able to come back with a plus 95% certainty of a relationship. Similarly, if you do have a plus 95% relationship in your Spearman's test, the graphs would have similarities between them that show that each data set its patterns and trends are looking similar, and those consistent similarities would support the idea why there's a relationship between the two sets of data. On to point 5. If you want to do further analysis, what you're really going to have to do is to look to other data sets. So for example, you might look at your land use map, and you might spot that the transect in question had an unusual pH amount, because by looking at the land use map you can see that there are coniferous trees, and those coniferous trees will drop needles, and needles can influence the level of pH in the soil. Those trees might be affecting the level of pH in the ground. Similarly, you might look at a data set that you have gathered somewhere else in your study, maybe the amount of shells at the beach, and you can graph those, and by looking at that graph you can see that there is a peak in the shell count at site 6, and site 6 is the one that has an anomalous pH score. It has a very high pH score, and you could say, well, maybe, given that Spearman says I don't have a relationship here, or whatever, maybe pH is not just influenced by the humus content. Maybe this very high number of shells at this location are influencing the alkalinity of the soil as the shells break down. By using another data set and looking at those data sets, you can normally find a reason why your data is doing what it's doing. Just to be clear though, if you are going to refer to another data set, you should probably include a graph of it so the examiner can see what you are seeing. In general, guys, your conclusion must be analysis related to the data you've gathered, and you're trying to spot and explain the patterns, trends, similarities and anomalies that you see within that data with reference to your hypothesis. Okay everyone, that's me. So if you've got any further questions, obviously you can find me in class or online. Cheers everyone.